Hey, hey, hey. Let's see. There we go. What? This is not it. There we go. That should be it. That looks weird. I'll just be like that. Hmm. So I'm sorry I started a little bit late. So the streaming app that we use has a new feature, which is like the vertical thing. Um, and I've been told to get rid of it. I don't know. It's been like 10 minutes that I've been wrestling with this. I can't. Um, but yeah, hey, hi, hey, thank you for joining, y'all. I really want to earn some good swags from LH, but don't know how to get it. Anyone, please help. Paste it on the Discord. Sometimes Way or other MLHers just send out like, hey, we're giving out free swag. Click on this link. Okay. Ask on Discord. And yeah. Hey, how are ya? Again, I'm sorry for whoever's watching on their phones. I know it doesn't look that good. I don't know. I have to ask my fellow MLHers because this is just weird. I don't know how to get rid of it. And I've been told, like they told me, like, hey, don't use it. Well, I don't know. There's a gear here, and nothing happens. There is not like a get rid of the vertical layout or something. Yeah, that's not good. Okay, cool. Won't waste any more time on that. Please let me know if my audio and my music is okay, okay? Cool. Before we start, please register here. Okay. Good. Fun fact. Yesterday I was audio is good. Thank you so much. Oh no, it's Quakers and cheese. Hey. Yep, that's good. Yesterday. Oh, so I've been playing with my computer, right? And last week I realized that my CPU's internal temperature spiked up to 95 degrees Celsius, and I was like, "What is going on?" Weird because the computer is like, yeah, it's Python related one. Weird because it's new. Like the computer has like a year, and I cleaned it up. So I opened it, I cleaned the dust out. It's good. I just checked the thermal paste. It was horrible. I had to change the thermal paste, and now with the same game, which is both Minecraft and Rainbow Six Siege, it's like a stable 70 degrees Celsius, which is good. So if you have a gamer computer, please give it some maintenance, okay? Not the temperature just spikes up, and that's not good for the computer. Cool, awesome. So let us start, okay? Let's see. Cool. So we're going to talk about MQTT and IoT. So if you've ever wondered how Internet of Things connects, then I'm going to answer that with some code and with some activities. Okay. By the way, we're going to use something called Wakui. Wakui is this one right here. What was the sound? There was a weird sound. Okay. This is Wakui. Okay, where we can simulate Arduinos, ESP32s, STM32s, and PyPicos. Okay, we're going to use ESP32s. If you could please create a user here in Wakui so you can use it too. It's going to be Arduino code plus Python. Okay. Cool. Okay. Nice. Again, what was that weird sound? Am I audible? Yes. Should be good. All good. Cool. Okay. So what is MQTT? So MQTT is a lightweight publish subscribe network protocol for machine-to-machine communication. Okay. Now, easy. Okay. It means we have a middleman that is basically making sure that your messages are the ones that you send are received by the other part. Okay. You can picture it as DHL, for example, or FedEx, where you send a package and they take care of the rest. Okay, you just put the address on. You say this is I don't know, a 32-gram box that I want to send it to. I don't know. I'm just gonna pick Quakers and Cheese. And Quakers and Cheese, I guess they live in, I don't know, let's say in Canada. So I'm going to send it to Canada and DHL takes care of that. Okay. That's MQTT. Okay. And it stands for Message Queuing Telemetry Transport. Okay. It's used widely with IoT. Good thing is it's free. Okay? That's a good thing. The bad thing is it's not as safe. Okay, so if someone has your link, if someone has your port, well, they can just listen to whatever they want. Okay, so be aware that even you, the code that I write, when I run it, you'll be able to send some messages through there. Okay, well, yeah, that's basically it. Okay, cool, nice. Now, next thing is we have some words that we need to understand. We have the broker, we have the publisher, the subscriber, and the topic. Okay, the broker is the server. Okay, the middleman, the one that receives all the messages and distributes them to the right clients. For example, we have Mosquito, double T. Okay, we have HiveMQ and EMQX. All three use MQTT. Okay, which is a protocol. Okay, MQTT is not a web page, it's a protocol. Okay, we have a publisher. The publisher is a device that publishes or basically sends out information to the broker on a specific topic. Okay, let's go down. The topic is a string. Okay, picture it as a walkie-talkie channel. You had to put a channel. And if both walkie-talkies are synced to the same channel, then they can listen to each other. If that doesn't happen, then you cannot listen to each other. Okay. So it's a string which has a name, and that's a channel that organizes your messages. Okay. For example, we have home/living room/temperature. Okay, that's a string. The slash is given by us. Okay, in the end, it can be home-living room-temperature or home.living-room.temperature. Okay, it's you can name it as you want. Okay, and basically you're connecting to a specific point or a specific subscriber that's listening to that same topic or channel. Okay, and that receives that message and does stuff with it. Okay. Usually the publishers are sensors and computers, and the subscribers are tools or actuators. Okay. For example, we can picture, in this case, for example, home, living room, temperature, which will be the theme of this stream. You can have a fan, okay, connected to the internet. And you might have also a sensor, okay, and that sensor is sensing your room's temperature. Okay, when the sensor feels that the temperature has reached a certain point, then it sends a message to the subscriber, which is your fan. The fan turns on, and whenever the sensor feels that the temperature is low enough, the subscriber just listens to the other command and shuts down. Make sense? Any questions, just let me know in the chat, okay? Cool. That's basically it, okay? Nice. Now, if people or if someone is not familiar with IoT, it stands for Internet of Things, okay? It's basically connecting your stuff to the internet, and you can control them through there, okay? For example, we can do a smart home, smart transport, smart farming, okay? You can see that they name it, or the name starts with smart. Okay, the way we do it is because, hey, it's smart because it listens to other sensors, and voila, right? That makes it smart. But it's not really smart. The smart one is you programming the IoT network. Okay. Cool. By the way, I usually forget. People just don't remind me about this. There we go. My name is Charbel, or people call me Bully. I am the program coordinator of the MLH Fellowship, and I'm also a streamer. So if you have any questions about the MLH Fellowship, please reach out on Discord. And yeah, I also stream here. So yeah, that's it. I'm a robotics engineer. I love IoT. I love everything that has to do with edge computing plus AI. So yes, that's what I like. Um, I had a piece of code that I was able to um, connect and control a light switch with my hand using computer vision and MQTT, and it just disappeared. So I was going to stream that, and I was like, "What the heck? Where is it? I don't know. I can't find it." But yeah, we'll do something else. But yeah, that's so sad because it's a very cool project. But yeah, I have to find the code because I don't know where I left it. Okay, cool. So again, any questions? Just let me know on chat. Okay. Cool. That's it. Now, if you want to start with IoT, if you want to start with electronics, Arduino, ESP32s, you need to know some things. Okay. We have microcontrollers. Microcontrollers can be an Arduino Uno, an ESP32. Okay. Those are not computers. Okay. People usually confuse microcontrollers with computers. Nope. Okay. Microcontrollers just receive information from an input, can be an electrical signal, process it, and sends out from another pin, okay, through another pin, the output. Okay. The sensors are the ones that usually you use for you to make decisions. For example, temperature sensor, proximity sensor, so on. Okay. Actuators can be as simple as an LED, which is a light emitting diode, a teeny tiny thing like this that you can connect to your Arduino, and it turns on and off. Relays or motors or more things. Okay. It's up to your imagination and your creativity to design something. Okay. If you want to start with IoT and microcontrollers, I like my advice is simulate it in either Wokwi or Tinkercad. Okay. And then when you feel comfortable, go into the hardware. Okay. Why is that? Because usually when people are learning, you tend to burn stuff, and you'll do it either way. Okay. I still burn stuff. Okay. I've burned myself lots of times just because I just don't pay attention and I connect a capacitor the wrong way and it explodes. It happens all the time. No worries. But when you are starting with this, it's easier and cheaper, basically, for you to use either Tinkercad or Wokwi or another simulator that allows you to burn things without actually burning them. Okay, sound good? Cool, awesome. Okay, so that's the presentation. Okay, long presentation. Let's dive into the code. Okay, now, if you see me go into this meeting, it's because I will use my Linux computer. Okay, so should be all good now. I should F11 this. Oh, there we go. And now to my other computer with my other mouse. Let's see. Why do you use another computer? I just don't like mixing operating systems. You can do a dual boot, I know, but I just don't feel like it. I don't know. It's my personal computer, my working computer. As simple as that. Yeah, so let's see. And by the way, Linux runs in a very old, like in wherever, okay? So if you want to use Linux, you should use your old computer. Some people say use Linux as your main operating system. No, like, not really, because, I just want to, if I'm using my personal computer to, I don't know, play or watch a movie or something, the last thing that I want to do, what? Oh, I got it. The last thing I want to do is actually look at code. So yeah, yeah, switch back here. My bad, sorry. There we go. This should be it. Again, that'll crash. Nope. There we go. Yep, no camera, no this. There we go. Cool, awesome. So now I will share my screen right now. Nope, entire screen. Yep, built in the screen. Share, should be able to see this. Yep, that's my screen. Thank you, Gemini. I don't care. And yeah, I don't care about this. I'll do this. You should be able to look at this neatly. Minimize this one. Can I minimize? Okay, cool. Like this. So I'm sorry if you hear my parrot. Do you hear my parrot? I'm sorry about that. She's just excited that it's raining. So yeah, I'm sorry if you hear my parrot in the background. Okay, cool. So this is the code that I'll follow. I'm sorry about that. Can you hear that? Is that if it's too loud, just let me know and I'll tell my mom to take her to another. Yeah, okay. Cool. Okay, so I'll just put my iPad here, so it's my cheat sheet. New folder. Oh, people that use Linux will just kill me for that, so I'll do t.ls, and then make their actually I should go to cloud, cd cloud, and then make their first stream. Cool, and then cd first stream, and then code dot. Cool. So open Visual Studio Code. Okay. Let's see. So I'll just zoom in. Maybe that's good. Cool. So where should we start? Okay. How? Why? What? How? Let's understand how this works. Okay. So we said we have a sender, we have a subscriber, we have a topic, we have a middleman, which is MQTT. Let's all relax and see how this works. Okay, so you're going to open a new Python program called let's do subscriber, like this. Okay, maybe I should do this like this. Cool. Okay, inside of subscriber, so you're going to import paho.mqtt.client as client, like this. You might see it's highlighted in yellow. It's because I need to download the library. Okay, don't do it yet. We'll do it together. Okay, we'll just ignore that for now. And we need a broker. The broker is that entity that will basically manage everything in the background. Okay, so broker equals in a string broker.hivemq.com. Simple. Okay, we are asking HiveMQ to be our broker. Okay, cool. That's the one I use. And again, since this is free, everyone can listen, send data through your link. Okay, so careful there. Cool. Our topic equals remember what was the topic? Someone remembers what the topic was? Topic in MQTT, not topic of the stream. Anyone? Any ideas? Y'all remember? Nope. Yes, maybe not. Okay, no worries. The topic is the channel that we're going to use to talk between one point and the other. Okay, we can call it whatever we want. Okay, just for the sake of keeping the theme of temperature, rooms, house, and everything, let's do IoT /room. Oh, my bad. /room temperature, like this. Okay, we keep that topic. It could be anything. Okay, cool. Now, this is the subscriber. Okay, now I want you to, what was that? I want you to look at me. There we go. Your ears. I'll take your ears as an example. Okay, your ears are set to on all the time. Okay? Even if you're sleeping, your ears are awake. Okay, so if someone talks to you, you'd probably hit him because it's 3 a.m. But yep. We have to do the same thing. It's not about we have to manually activate the code whenever we send something, because that doesn't make sense, right? And we cannot freeze the entire thing, the entire computer, just to listen. For example, while true, listen, and you're freezing a thread in there, and your computer, you're using a thread in your computer that's just frozen. Okay, so what we have to do is activate the ears, put them in sleep mode. Whenever we get something, we actually do something with it. Okay, cool. Pause this notification. Yep. Cool. Okay, so going back to our code, we do def, which is if someone is not familiar with Python, please let me know on the chat so I can go slower. Okay, it's not bad. Okay, but I'll assume you know some Python. Okay, cool. So def on message, and then we need a client. We need user data and a message. Okay, like this. So this is what's good practices with Python. Always when you create a function, please give it some comments, okay, for you to come back and see and understand what you did. So we can say, hey, this function takes care of handling the messages when they are sent through the broker. Okay, so far so good. Okay, is it? Yeah, I think it's zoomed enough. Okay, so we're with temperatures and stuff. We have to get the temperature, right? So temperature, yeah, that should be good. Equals float. We want to make sure it's a float. Message the payload decode, like this. Okay, it means whatever we get, which is a message, I get the payload and then we decode it. Okay, we float it up and it's in temperature. Okay, cool. Now we have to have, let's simulate for now, and we'll do it in a real case scenario later. Let's simulate our fan. Okay, so the fan should be on if the temperature exceeds 30 degrees Celsius, and should be turned off if the temperature is less than 30 degrees Celsius. Okay, sound good? By the way, no one told me about the banner. There we go, that's better. Okay, so let's do that. Status equals fan on if the temperature is bigger than, let's say 25. Okay, else fan off. Okay, and then print, and I print received temperature, my bad, temperature in Celsius, and then status is status. Cool. Okay, so far so good. No questions. Nice. So now, even though like we want to use client or data, so we can do underscore. Okay, I know that's good practice. In this case, not. Maybe it's underscore. But we'll leave it like this. Okay, just so we know what should be going here and here. Okay. Yep. So far so good. Nice. Thank you. Cool. Okay. Now we should connect to the client. Okay. MQTT. Oh, I'm sorry. Client equals MQTT dot client. This should be MQTT. My bad. Like this. Okay. My bad. MQTT dot client, capital C. Okay. And then client dot on message equals on message. Okay, what are we doing? Like, what does this mean? Okay, we have on message, and we say client on message is on message. So in the background, oh yeah, for sure. You have to encode it so it's easier to send. Okay. It's not hashed. It's not like a difficult coding. It's a coding inside of MQTT. Okay, so it's decoded to send it easily. You won't send a string. You would send binary. Okay. So that's why we don't use a seed or anything fancy here or a key, just because it's like it uses the same key for all of them. Okay. But yeah, ideally you should hash it. Okay, so no one, if someone connects to your IoT, like the web that you have in your home, you should hash it or do something with it, just so it's not that open to the world. Okay, but yeah, cool. Okay, so what we're doing is we're saying, hey, from Paho MQTT client, we get the object. This is the object. We're saying, hey, we know we have an on message, yet this on message doesn't do anything. It's waiting for us to write it. It's basically saying, hey, I help you out by activating the ear, but I just want to know what you want to do with that ear. This is what we do. Okay, so we're saying, hey, that ear is going to react like this whenever it gets a message. Okay, cool. Now, by the way, no parentheses here because we're not activating the function. We're just grabbing it and putting it somewhere else. Okay, cool. Now, client.connect. Okay, broker. We connected to the broker. The next argument should be your port. Okay, you can add whichever number. I'll add 1883. That's the one that you usually add. And then 60. Okay, cool. Now, client.subscribe. And we'll do topic. Okay, so this is a subscriber. We subscribe to the topic. The topic is room temperature. Okay, because it could be room light or I don't know, room TV, room bathroom. Okay, I don't know. It can be anything. Okay, but we know it's in the room. Okay, nice. We connect to that topic, and we print listening for temperature updates like this. Client.loop forever like this. Okay, now you'll say, hey, you said that we were not going to use a while loop, and yet we're looping forever. It has to stay on, okay? But it doesn't mean that we have to freeze the thread, okay? MQTT manages that for you, okay? The thread is available, it's sleeping in your CPU, and it's not using like a thread. Okay, it's less payload. Okay, cool. Now I know we haven't downloaded this. Yes, we'll do it. Okay. Now, if you have a subscriber that is listening to something, we need a sender, right? So let's do that. we have subscriber, and we have to have a publisher. Okay, publisher.py. Okay. Funny little. What is that? Is that like a mermaid? Okay. Is that like a frog? I'm not sure. StreamYard has weird emojis. Cool. Okay. So from the publisher, it's very similar. Okay. We have import bajo.mqtt.client as MQTT. So far the same thing. Okay. Import time and import random. Okay, like this. So next one is broker. It's the same thing. Yes, you can make an object and inherit every single thing. Yep, that's basically it. Cool. So broker is, remember, it was broker.hivemq.com. Remember, broker is the middleman, the one that takes your message, puts it in a cart, and puts it in the destination. Okay, cool. Now, topic equals, remember the topic? It was IoT/room/temperature. Okay, cool. Now, client equals MQTT.client, same thing. Okay. Initiating the object, and then we do client.connect broker port number time to live. Okay, and then while true, this is the one that's going to use the thread because it's an active sender. Okay, you could be reading sensors, you could be sending information, I don't know, sensitive information, whatever, they should be active. Okay, so it has a while true. Temperature equals round random dot uniform between 20, let's see, between 10 and 40 to 2. Okay, why is that? Because we have to round the number up to 2 digits. Okay, rounded the uniform gives you a float. Okay, so we just rounded to 2 digits. Okay, cool. Now, client did publish. We publish where or to whom? Topic. Whoever is subscribed to that topic will get my message. And what's the, oh, my bad, temperature. There we go. And what's my message? Well, the temperature. Okay, so far so good. Cool. Now we print, just because we want to make sure that we know whenever we send a message. Published temperature. And then there we go. Temperature in Celsius. And then time.sleep 2. Now time.sleep is not the best option. Okay, there are better options than time.sleep. Time.sleep freezes your thread. Okay, so if something is using that thread, it won't be able to use it because of time.sleep. Okay, so it freezes the entire thing. Okay, for now it's okay because we're just doing this. If you're doing things asynchronously, careful. Okay, cool. Okay, now how do we run this? In my case, I have Linux, so I'll do it like this. If you have Windows, I'll explain it to you in a second. Okay, we have to open an environment. Okay, so a Python environment enables you to install libraries without touching your source Python. For example, if you're going to use Bajo MQTT client, then what you need is maybe you won't use it later, okay? But if you download it directly in source of your Python without opening an env, then if you have a conflicting library in your source, it's going to be a pain to find it. Okay, my experience. Okay, cool. Let me just remember what the name was of this. My requirements. Should be hello. Huh. Interesting. Deep sword. Nope. 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 Wait a minute. What's the Polaris protocol? Parsing. YAML. Nope. Setup tools. Storage and storage vision. Interesting. What's the name of this? Bajo MQTT. I'll look for it if I don't. Maybe it's like Bajo. So first, we have to do Python 3 in case of Linux and Mac -m -v. Okay, and then the next argument is the name of your environment. In my case, I always use env. Okay, it's easy. Okay, it's env can't be mistaken for something else. Okay, that's what I do. Okay, wait for it to think. Voila, should be good. Now, if you're a Windows user, you do pi instead of Python 3 -m -v env. Ah, thank you. It's Bajo MQTT. Cool, thank you. Nice. This is for Windows, okay? And maybe I should do like this. Okay. This is for Windows users. For Mac users, this is the one that you use. Okay. Cool. Now, I won't run this. It'll just throw an error just for you to see. I can't understand what pi is, but Windows understands, okay? Cool. Now, if I want to activate this environment, in case of Linux and Mac, which both of them have underwater or like under the hood, they have Unix, okay? So it should be source env bin activate. Okay, this is just for Mac and Linux users, okay? Enter and you'll see env here. As for Windows, you have to do instead of source, you just directly do env scripts and then activate like this. Okay, that's only for Windows. Okay, cool. Now, thank you, beep67. We can do pip install Bajo -mqtt like this. Okay, it's already installed. And if we go to our Visual Studio, should be here. Yeah. Okay. This should be gone. Maybe it'll take some time. Okay. Yep, Python should be good. Yeah. I don't know why it's marking it like this. We should test that. Okay. Cool. So we go here. In my case, it's easy for me because I can open multiple terminals. Okay. You can open different instances, but in this case, for you to see. Okay. Actually, not like this. Maybe horizontally like this. It looks better. Okay. Cool. So, source env script open activate. There we go. Cool. Yeah. Okay. Cool. So, and the first one, I'll do pi. It's Python 3. My bad. In Linux. Subscriber.py. Okay. It is. I'm listening for the updates. I'm just listening to it, waiting on someone to talk to me. Okay. In this part, I'll do Python 3. What's it? Subscriber and publisher. 3, 2, 1. I'll click. And I'll send 17 degrees. Fan is off. I have 18.68. Yeah. Fan is on. On. Check that out. Isn't that cool? So I can control from this side over here what happens here. Now, you'll probably say, hey, I'm pretty sure that doesn't have to do anything with IoT. It's your computer. So I will challenge if someone is following my code, I'll open the subscriber, leave it running, not run the publisher, and wait for someone to send a message, should be a number, to my computer, okay? Remember, you should be using this broker right here, this topic right here, this port, and this TTL, okay? I'll see if someone is following my code. Let's see if someone, okay? I'll give you 1 minute. They'll give me time to drink some water too. So that way you'll see that it's not, even though it's free, it's not safe, okay? Maybe I'll do, no one? Okay, maybe I'll do this. Should I paste it here, maybe? Cool. Yeah, and then I'll get this code right here. If someone wants to run it, cool. If someone wants to run it, I'll give you 1-2 minutes for you to run it. You saw how. And you can send me information. Remember, topic has to be the same. Broker, there you go. I don't know who's sending that. Whoever is doing it, see that? I'm getting it here. Yeah. Yeah, you're good, you're good. See, now this shows my point, right? Like, whoever it is, it's not in my local web, so it's not in my home. That person is probably not in Mexico. That person is outside of Mexico. So it's a worldwide communication that's happening real time. Well, real time. And I'm getting it. That's really cool. That's not very safe. Okay, just be careful with everything IoT related. Okay, because this can happen. Okay, if someone knows your port, if someone knows your topic, it's an easy access. Okay, you might say, hey, it's a lot of things, right? Like, they have to know my port. It's not that hard. Okay, cool. Whoever sent that, thanks so much. Nice. I'll just close it here. Okay, cool. So what can we do with this? So we got someone that listens, someone that acts when we listen. IoT has lots of uses. Okay, something that we usually do when we work with IoT is have some logs. Okay, we want to see everything. Okay, for example, if you want to follow your room's temperature, then we have to do a graph, create a graph, do it in the server, and then have that sensor send to your computer and to your actuator. Yep, your information, so that the actuator either turns the fan off or on, and your computer to register the log. So if you're in Acapulco, for example, or if you're in, I don't know, Miami, maybe Fiji, okay, and you wonder, hey, is my home cold or not? You open your phone and you're like, oh yeah, I can see the logs. Okay, cool. So get rid of publisher, get rid of subscriber. Okay, we'll open a new one. That new one will be called dashboard.py. Cool. Now, in dashboard, we're going to use something called Streamlit. Okay, Streamlit is a Python library that lives in HTTP, which is a hypertext transfer protocol. Okay, you can, such as Flask or other APIs, you can put something in your server, localhost, and you can listen through other ports. Okay, that's what we're going to do. Streamlit does a great job by simplifying everything, so we don't have to manually do the graph. We just use the graph. Okay. Okay. Maybe. Okay, I'll do something. That's a good question. Okay. Cool. So we have paint. Okay. Now, we have okay. Before I start drawing, I don't know how to draw with a pen or with a brush. It's like if I'm horrible doing that with the tools that are made for drawing, I'm way less skilled in my mouse. Okay, I hope that this makes sense. Okay, so we have one, we have another one here, and we have the broker. Okay, now this is Hive MQTT. Okay, so far so good. This is what is listening to your internet. This is the middleman. Okay, now let's say that you have a garden. Okay, and you want to know if your plants are okay, right? So in your garden you have maybe like a humidity sensor. Okay, and in here, this is your actuator. You have water. Let's call it like a water activation. Okay. Yep. So if this sends a message, humidity sensor sends a message, we need someone to be in between to talk to the water activation. So I have to send a message here. And then Hive MQTT says, okay, I get it. I will send it to the person or the thing that's waiting on me to send it. And then Hive MQTT says, who's that? So we say, oh, Hive, I got it. I got you, right? I wanted you to send it to IoT/room/temp, right? Okay, so Hive MQTT says, I got you. I will send it to whoever is subscribed to IoT/room/temp. Okay. Now, this thing over here, the water activation, is waiting. Okay. And this thing is also subscribed. We can picture this as an antenna to IoT room temp. Okay. And because these two are the same, then they can connect to each other. So message goes from Hive MQTT to whatever it's listening. Okay. For example, what happens if in your publisher, for example, instead of IoT, we write IoTS. See that? Instead of IoT, it's IoTS. Okay, so it's a very different topic. Okay, let's go activate the subscriber, activate the publisher. I'm sending temperature, and yet the subscriber is not getting it. So in this case, this can be, or this is simulating a sensor, a temperature sensor. And this is your fan. Okay, this is the fan that you're using to cool your room. Okay, it's not getting anything because it's not related, because the topic is not the same. See that? If we say, hey, I got you, it's IoT room temperature, and I run it here again, I see that? I got it. 28, 15, and based on what you get from the publisher, you can react to it. Fan on, fan off, fan off, fan off. Does that make does that make sense? Is that a little bit better? Yeah. So picture wait a minute. Picture The relationship is here. This is the only thing that it makes the relationship between one end and the other. Okay, if this is different, they just don't relate to each other, right? Because they're not talking to each other. It's like having a temperature sensor for your washing machine. Okay, the temperature sensor is in your room, and the washing machine is washing your clothes, basically. So it doesn't make sense, right? And if you have them both listening to the same topic, that wouldn't make sense. That wouldn't change how the washing machine washes your clothes, right? You relate them using the topic. Okay, good, awesome. Nice question, though. Very, very, very good question. Cool. So, nice. So let's get rid of this. Oh, my bad, not dashboard. Cool. Okay, now let's visually see prettified this. Okay, so import, and I'll get rid of this streamlit as st. Okay, I know we have to download it. No worries. As always, import bajo.mqtt.client as mqtt. Same thing as before. From collections, import DQ and import time. There we go. Necessary libraries. Okay, cool. Now, what's the next thing that we have to do when you're working with this? Broker equals broker.hivemq. Just unplug my computer. There we go. hivemq.com, and topic equals IoT / room / temperature. Okay, it can be another topic. Okay, what we need to do is both of them have to be the same. Okay, both endpoints. Okay, cool. Okay, so the temperature equals DQ, which is this collection's data type, which max len equals 50. Okay, we'll just do a queue of 50. Okay, cool. Now, streamlit, the title. Okay, always add a title, because if not, then we don't know what we're doing. Is IoT temperature dashboard, like this. Okay, simple, very explanatory title. And we need a chart. Okay, based on what you're measuring, you'll need different. What is a chart? It's like measuring tool. Okay, so for example, in case of maybe humidity sensors, temperature sensors, proximity sensors, maybe we can draw a chart, and that's helpful. Okay, you wouldn't use a pie chart, for example, for temperature. Okay, cool. So we do chart equal st.line chart. Okay, inside of it, nothing. Okay, cool. Now, the dashboard. Okay, question for everyone. Would the dashboard be the publisher or a subscriber? What do y'all think? What is your guess? Or maybe not guessing. If you paid close attention, you might know the answer to it. This dashboard that we're going to do, is it a subscriber? Is it listening to data? Or is it a publisher, something that's sending data out to the world? Anyone want to take a guess? Nope. Nope. Really? Okay. Easy. Your dashboard is. Oh yes, there you go. Yeah. Thank you, Karime. It's a subscriber. Okay, it's something that's listening to your commands. Okay, because you're going to send information to it, and it's going to react to it. Okay, thank you. Nice, you earned a star. There you go. Cool. Awesome. Okay, so then we need to do the on message. client, user data, and then message. Okay. Oh no, no way! It's not the bully. It's 404. Hey 404, how are you? Nice to have you on my stream. It's been a while. Is that a Harry Potter hair with glasses? That's funny. Yeah, nice to have you here, 404. It's been a while. I haven't seen you in like 2 streams, like 2 global hackways in a row. Cool. Okay, nice. So, on message, okay? Now we have the temperature. Let's call temperature message equals, again, float, okay? You didn't hackathon, sadly, you're busy. No worries at all. You know, you have priorities, but yeah, nice for you to come and visit me once in a while. That is indeed Harry Potter, one of the best movies and books you can ever read. Also, it looks so cool. Thank you so much for. By the way, I have the entire collection of Harry Potter books right up there. And it's not only the books, but also the limited edition house books. So if you put them one after the other, the 8 books, no, should be 7 books. It's a whole big image. You can see Nagini just go through all of the books. But yeah, cool. I'm also a Harry Potter fan, by the way. Cool. Okay. Nice. So we get the temperature message. It should be a float. Okay. Remember, message the payload dot decode. Okay. Not a very fancy code. It's just an MQTT coded. Okay. Nice. No cursed child. Oh no, that's not. As far as I know, that's not canon. As far as I know, that's not canon. 7 books. 7 books only. Good. Okay. Temps should be temperature dot append, and then temp. Okay. By the way, should be temperature message. My bad. And in what? Like this? What? Control C. Control V. Oh, there we go. I'll do temperatures with S right here. Okay. Temperatures, just because we're keeping track of temperatures. Okay. Cool. Okay. Nice. So, as a usual subscriber, client the equals MQTT dot client capital C. Okay. Client dot on message equals on message, like this. Remember, we're picking this function and rewriting the on message function that's already there. Okay, cool. Now, client dot connect where broker 1883.60. Okay, I'll do the same port, same broker. Okay. Cool. Now, client dot what? If this is a subscriber, that subscribe, and then inside of this, we'll get the topic. Okay. Now, client dot loop start. Okay. Now we need a placeholder. Okay, somewhere that we can put our chart. So easy peasy. Placeholder equals streamlit.empty, like this with a T. Okay, cool, nice. Okay, so this is the main streamlit loop. Okay, I'll leave it as a comment so everyone can know that this, from now on, this is pure streamlit. Okay, well, true. Now, if we have temperatures, then please, placeholder, I want you to draw a line chart What's wrong with my typing today, chart? There we go. Chart. Dot line chart. A list of temperatures like this. Okay. Now, time to sleep 1. Why do we do time to sleep? Like, what? Why? Like, if it freezes the entire what's this called? The thread. Yep. If it freezes the entire thread, why do we do time to sleep? We need the CPU to rest. If you don't time that sleep, if you leave it as while true, your CPU overloads with the while true. Okay, you don't want that. You want it to have at least 1 second to do other tasks. Okay. Again, if you have multiple instances of Python running or async things running, careful with sleep. Okay, because it freezes the entire thread. Okay, cool. Now, let's look at it, shall we? Now, funny thing, I don't remember how to. Does this work? Oh, by the way, we have to do pip install. Streamlit like this. Okay, should be connecting lots of things. And by lots of things, I mean lots of things. Yeah, you know, we can talk about Harry Potter. Since 404 is here, yeah, I have all the movies, by the way. Also, it's the limited edition of the house as well, like the box. I have Tom Riddle's notebook, and you have a pen, which in that pen writes like invisible ink. You have to have like a UV light to see it. I'm a very fan. I'm a huge fan of Harry Potter. And do I have a wand? I do. Yes. Who doesn't have a wand? Okay. Now, does this work like this? Python 3. Dashboard. Yeah, that should be good. That should be good. Okay. Cool. Now, if you see, oh, here it is. Okay. It should be streamlit run dashboard.py. Okay. So streamlit run dashboard.py. Okay, that was the one that I was looking for. Cool. It says, hey, welcome to your Streamlit. If you'd like to receive helpful onboarding emails, news, promotion, blah, blah, blah. You can, even the occasional swag, you can drop your email here. I won't. Thanks so much, Mr. Streamlit. I'll just enter it, okay? To Windows. Yeah, maybe. This is need? No, I don't want this. Okay. You can see we have a network URL and a local URL. So everyone can access through this. No, this is not. 192.168.102. If y'all type this and you do not run Streamlit, this won't be accessible to you. How do I know that? 192.168.100. Usually whatever starts with 192.168 means local. Okay? It's in your local, your house, your workplace. It's your local network. Okay? 192.168 always means local. Okay? I can have a 192.168.102. 404 might have 192.168.102. And both of the IPs would show different things. Why? Because it's only a local IP. It's not a public IP. Okay? Cool. Now, you can do also localhost in this case. Localhost, which is 0.0. No. Localhost is 182. Darn, what was localhost? Was it 0000? Like 4 zeros in a row? I'm sorry, 0001 should be. Because the 0 at the end is a broadcast. I don't remember what localhost was. But yeah, we can go here. We'll check that out. So it says IoT temperature dashboard. Oh yeah, that's true. It's 127.0.0.1? Was it that? I don't remember. Yeah, you're true. Beep, beep. Okay, we have the IoT temperature dashboard. All cool. And yet we have nothing. we are just missing the publisher, right? So why should we write more code, right? Why couldn't we just do publisher? We're publishing temperature. Ooh, check that out. So we're getting the temperature, and yep, you got it there. See that? So we can get more fancy with Streamlit, which I won't dive into because this is not a Streamlit stream. But using Streamlit is a very efficient way to read your data. Is it data or data? I'm not sure. I think it's data. Okay, so your data. Now, yes, we're oscillating from, I think it was publisher. We're going from 10 to 40, okay, which is not a very normal thing, but we can even oscillate from, I don't know, from 20 to 22. That's a very like a more accurate reading. We won't like, there is no room in the world that would change 2 degrees in a second, but you know, it makes more sense. Okay, see that it's running by itself. Okay, see that you can move it around. That's cool. Scroll to zoom in, zoom out. Okay, not a lot of code. If you see, it's just this. Oh no, this is not dashboard. It's this. Nope, not this one. This one. See that? It didn't require lots of code. Okay, it's not like Flask that you have to create the entire thing by scratch with HTML and CSS. I'm sorry. It's simple. Streamlit is really cool. Okay. Cool. Questions? Any questions? Oh, by the way, I'll just. There you go. No, you can get more fancy and write more text here. You don't have a chart. Did you run your publisher? So again, because the chart only activates if you have temperatures. If you don't have temperatures, then the placeholder is empty. Okay, did you run your publisher? Maybe you did, and maybe the topic is not the same, or maybe the broker is not the same. Yep. Let me know. Okay, all good? All good, all good, all good? Nice. Okay, cool. Now, let's stop this. Double, I don't want double, thank you. I will check now, yeah, double check. Cool. Okay, now, this is in theory, okay? This is all theory. Let's kind of put everything together, okay? So we talked about, and give me 1 second, I'll do this because sun, I don't have a lot of sun right now, so just give me 1 second. I hope this has battery. I didn't charge it. I didn't think that I was going to run out of light. Is that good? Better? Yeah, nice. Okay. So we talked about WOCWI. We talked about Arduinos, ESP32s. We're going to work on that. Okay. Cool. So let me just read my WOCWI Arduino. There we go. Okay. Yeah, that makes sense. Cool. Now I'll put my computer, this computer right here. Okay. There we go. So this won't work now. Okay. Now I'm doing it in my personal computer, so you see the computers are not even connected to each other. Okay, so it's not the same computer. Okay. Open WOCWI. And inside of WOCWI, you will see this. Okay, if you don't see it, click here and click My Projects. And then New Project here. Okay. Now, we need an ESP32, a regular ESP32. Okay. connect here, and click on Arduino. Okay, cool. Now you have this, okay, which I'm not sure if, can I zoom in? Like this, that's better. Cool, now this is an ESP32, okay? This is a microcontroller, it's small, it's like yay size, okay? It's really useful because it has Wi-Fi integrated to it, okay? So you can connect Wi-Fi to this, okay? Now, in the library manager, you need, was it MQTT? I don't remember. Wait a minute. Yeah, leave. I don't remember. Library manager. We need pops up client. Okay, so Control C here. Click on ESP and then click on Arduino. Go into library manager, plus sign, pop sub client like this. Okay. Should be this one right here, pops up client. There we go. Okay, it's already installed. Okay, cool thing about Wokwi is that we can connect the simulation to real internet. Okay, cool. Now, first of all, we're going to draw. We're going to put it here. Okay, the components. Okay, cool. So, what do we want to do? Like, what is it that we want to do? We want to turn the fan off if the temperature is lower than a certain temperature. Turn this fan on if the temperature exceeds the temperature that we want, the threshold. Okay, so if you're not familiar with microcontrollers, I'll give you a quick tour, okay, because we're running out of time. ESP32, and ESP32 pin out. There you go. This is how this looks. Like this, okay? Each and every single one of these dots are pins. Pins is where you connect your electronic devices. You can connect an LED. You have to connect power, stuff like that, okay? You can see all of these are GPIO, okay, which is input output, okay? Some of them have, for example, some of them have clocks. I can't read it, it's a little bit. For example, this has ADC, which is an analog digital converter, okay? This one doesn't have ADC. See that? So some pins have different characteristics, okay? Cool. Now, this is how it looks in real life. You should connect this to your computer. For now, we'll simulate it, okay? Cool, so get rid of this too. Okay, nice. So these are the pins, okay? For example, this one has 5 volts. This one has 3.3. And this is ground, okay? Cool. So, click on the plus sign. We don't have a fan, sadly, in Wokwi. What we do have is an LED, okay? We can have an LED that will act as our fan, okay? Let's do it as like a purple one, okay? Cool. Now, you see A for the LED stands for, this is the cathode and this is the anode, okay? Cathode is the positive, anode is a negative. Am I correct? LED, anode, and cathode. Am I correct? The anode is a positive, the cathode is a negative. Okay, anode positive, cathode negative, okay? Anode, this one, should go to the positive. And cathode should go negative. Negative is our ground. Look for the pin that's called ground. Could be this one right here, or I think there's another one right here. Okay, we have 2 grounds, with this one and this one. Either would work, okay? Now, you'd say, hey, put this in 3.3 volts. Well, yeah, but that won't change anything. It'll be on forever. Okay, then why don't we instead of doing this, how do you remove this? Yeah, there you go. We do 5 volts then. Well, you'll say goodbye to your LED. It's super bright, and you should never put your LEDs with 5 volts. Okay. Without a resistor, by the way. Yeah. So that will stay on. So we need pins that we can control. Okay. So am I audible? Maybe do this. Do this, maybe. I froze for a bit. Am I okay? I'll just leave the call just in case. Cool. Okay. Am I good? I'm seeing that the camera is a little bit weird. Let's see. Am I okay again? Yeah, should be good. I don't know if it's Wokwi. It's Wokwi. What? Really? All good? All good? It's good? Yeah, okay, cool. I think for some reason the camera will lag if I touch Wokwi like this. See that? I have to... Yeah, that's weird. Okay, cool. So maybe should I do it in the other computer just for me not to lag? Okay, I'll do ESP25. That's going to be the pin that I'm going to work with. Okay, cool. So far so good. Positive goes to 25. Cathode goes to not 5 volts. Actually this is wrong. Wait a minute, what? We said anode was a positive. So anode goes to 26. Cathode goes to ground. Where is ground? Here it is. Okay. Oh, good. Nice. Cool. Now, what is this? Like, what is this right here? This is where you'll put your code. Okay. Setup is the function that Arduino, or in this case the ESP, uses to set up the pins. Loop is your while true. Okay. After this runs, this will run forever. Okay. In this loop, you can put different functions if you want them, but it always, like, you cannot delete these two. It's going to be an error. Okay, that's how it works. Okay, cool. Now, this is a C++ code, so we have to do hashtag include, and then we do bigger than and smaller than sign, and we do Wi-Fi.h. Okay, Wi-Fi capital W. Okay, cool. Now, hashtag include. If you're unfamiliar with the code, hashtag include is like doing in Python import. Okay. Pub sub client .h. Okay, now you need this for Wokwi. Okay, I don't think you need this for your ESP32 at home, but for Wokwi you did this. It creates the tunnel between Wokwi and internet. Okay, cool. Now we're going to do a const char, which is char star. It's a string called SSID. This is just for internet purposes on Wokwi. Okay, this should be the same for you too. Should be Wokwi -guest. Okay, const char star, which is a string. Password, we don't have a password in this case. Okay, should be left that way. Now, const char star MQTT server equals broker.hivemq.com. We know that, right? Like we're used to this. Okay, cool. Now we have to do Wi-Fi client, PSP client, like this. Oh, my bad. Wait a minute. I'm so used to Python, I usually forget semicolons. And then we do pub sub client, and the object is client, ESP client, like this. Okay. Cool. Now, you see this light is connected to 26. So we'll do const int, right? Const means constant, okay? So something that doesn't change. Integer, let pin equals, in our case, 26. If you put your light here, it should be 25, 33, 32. It depends on where you connected it, okay? Cool. Now, remember what we did? We had to do a callback, which is your ears have to be activated whenever you get a message, okay? This is a subscriber, okay? This is your fan. This is whatever is listening to your temperature, okay? Cool. So yeah, that should be good. Void in C++ means that the function won't return anything, okay? So void callback like this, and then it's char star topic byte star. This is stream of bytes payload and unsigned int length. Oh, my bad. Like this. Okay, maybe I'll do this so you can see everything. Okay, cool. Now, inside of this, string message like this, and then we do for int I equals to 0, I is less than length, I plus plus. Okay, now this is not Python. We have to do some things from scratch. For it, we have to loop through the message and say, hey, message plus equals. So we're appending to the message string char payload in I. So far, so good. Yes. So we're in our message, we're adding to it character payload in I. I is a number from 0 to length of this payload. Okay, cool, nice. So, let's do if. Let's do int. Let's do char. Let's keep it in char for now. If message double equals on, then we do digital write. I'll explain what digital write is. Digital write let pin hi. Okay, so what are we doing here? We're going to send on and off messages, okay, from the other computer. If it's on, then your let pin should be high. Let pin is number 26. 26 is our pin to our left. Okay. Now, what does digital write mean? It means I want you to digitally. It means either 0 or 1 or 0 volts and 5 volts. I want you to send that to the let pin. Okay, and maybe people will kill me just for this, so I'll do it. If someone is an electronic engineer here, my bad. I'll do it the correct way, which is adding a resistor here. Okay, you can leave it without the resistor. Okay, just for people who know about this. Because if you add 5 volts to your pin, I'm sorry, to your LED, it can burn. Okay, so if you add a resistor, just for good sake. Okay, cool. Okay, so we say, hey, I want you to write high, which is 1 or on, to the LED. Okay, cool. And then we do serial that print line. The LED is on like this. Okay, cool. Now, else if message double equals off, then we do the same thing. Digital write should be let pin, okay, and we instead of high should be low. See that we didn't declare low or high. By default, the ESP or Arduino understands it. Okay, cool. Now, and then we do serial.print line. The LED is off. So far, so good. Nice. Okay. That is our callback. That is our on underscore message for this app. Okay, cool. Now, we will do. We have to connect the ESP to the internet. If it disconnects, it has to be able to reconnect. Okay, so let's create this function void reconnect like this. Nice. So let's do what I said we would do. Add your comments here. This is the callback for that listens to the messages sent through the MQTT topic. Okay, always leave some comments. Should be function that takes care of the internet connection in the ESP32. Okay, and happy face just for good measure. Okay, cool, nice. So we do while not client that connected. Now I'll explain what this means if you're not familiar. If you add a exclamation point before something, it means not. Like if this is false, then, or while this is false, then serial.print line, and we do, or let's print like this without a line. We don't want each line. Connecting to MQTT, 3 points. Okay, semicolon as always. Okay, now if client did connect, inside of the connect we are connected to Woku we client, then serial.print line, we print connected. Okay, cool, all good. And then we're connected, right, to MQTT, but we need to subscribe. Okay, if we're not subscribed, then we cannot listen. Okay, even though we're listening to something, we don't get it, right, because we're not at the same topic. So in this case, let's call the topic client shoot dot subscribe, where, since this is a light, we're going to simulate a light. Let's do IoT slash home, I'm sorry, slash, let's change it a bit. Let's do garden slash light. Yeah, sounds good. Okay, cool. And that should be good. Now, if it's not connected, then serial.print failed, and the reason would be like this. Okay, that's the reason. And now we do serial.print line client.state like this. Okay, so we print the state, and this is the state. Okay, cool. Now, if it doesn't connect, let's do a quick delay, which is like a sleep of 2000 milliseconds. Okay, it's 2 seconds. Okay, now I'll go through what we just wrote down here. If we're not connected, or while we're not connected, let's print connecting to MQTT. And then if we connected to something, we print connected, and then we client that subscribe to this. If we're not connected, we print failed. The RC is the state of the client, and we wait a little bit and we retry. Okay, cool. Now, let's go to void setup. Okay, serial that begin leave it like that. Those are the bots or the frequency of the ESP32 to read the serial. Okay, leave it like that. Get rid of this. We do pin mode, let pin, and then output. Like this. What does this mean? It means I want you to put the pin, let pin, which is 26. I want it to be an output. It means voltage will go out of the pin. Okay, cool. Now, having said that, we will do Wi-Fi that begin, SSID, and password. In Walkwee's case, this is our SSID and this is our password. If you're going to try this at home with your own ESP32, it should be your SSID and your password. Okay. Okay. What is the SSID? It's the name of your network. Okay. Cool. Okay. Now, while Wi-Fi dot status is not equal to connected, then we wait a little bit, delay 250 milliseconds, okay? And then serial that print a dot. Okay, so we can see dots whenever it's not connecting to Wi-Fi, okay? Whenever it's trying to connect, basically. Okay, cool. Now, if we got out of this while, it means Wi-Fi is connected. Okay, we're good on that. If Wi-Fi is connected, then serial that print. Let's read online so it's easier to read. Backslash, I don't know how to put a backslash. Is it like this? How do you do backslash? I'm not sure. Backslash n, which is an enter. Wi-Fi. Okay, like this. Okay, cool. Now we do client dot set server. Which server? MQTT server. MQTT server is found right here. See that? And the port, let's just use the same port, 1883. Okay, cool. Now, client dot set callback should be callback. Now, this piece of code is the code that was client.onMessage equals onMessage. That's the same thing here. Okay, cool. Now, semicolon, so we don't get errors. There we go. Cool. So it's already ready. We will turn the let pin on if it's hot, if we get on. If we get off, then we put let pin in loop. Okay. In the loop, we're going to do if, just in case the client is not connected, then reconnect. Reconnect. There we go. Okay. So this loop will loop forever. Okay. Cool. Now, this client.loop means client, which is our our web pops up. Okay, this web pops up right here. Okay, if this client is not connected, then we reconnect, and then we loop. Okay, okay, nice. Yeah, should be good. Should be good. Cool. Okay, now I'll run it here. Start the simulation. Let's see if everything's correct. There's not a lot of server what? Wi-Fi.h, no such file or directory. Oh, my bad. It's Wi-Fi with capital F. Okay, Wi-Fi, capital W, capital F. Okay, run it again. So it compiles. Let's see how it goes. Should be all good now. You have to compile it just once. So I'm compiling it. If you run it again without, so if it says it doesn't have errors, and without changing the code, you run it again, it won't take time to compile. It stays compiled. Okay. So we have to just wait a little bit. What? Oh, Wi-Fi client, capital W. I'm sorry, capital F. See that? Whenever you get errors, don't run from errors. Okay, don't paste that to an LLM. Read it. Okay, it helps you learn. Did you mean Wi-Fi client? That is true. Wi-Fi client, and then it said PubSub client. There's not a name type. Did you mean PubSub client? Capital P. My bad. Cool. Let's recompile. Okay. Let's see. Should be good, I think. Oh, I'll get an error here. No, I won't. Yep, I will. This is not. Yep, I got it. This is not a colon. It's a semicolon. My bad. See that? Int I equals 0. I is less than length. I plus plus. Okay. Nothing more. Do I have an error here? Wi-Fi capital F. Capital F. What else? Semicolon here. What's wrong with today's typing? Should be all good then, I think. Let's see. Let's wait. Is it? Nope. Yes. Tammy is not here. Tammy usually counts the number of errors. So honoring Tammy's task, I'll say this is the third run. Okay. Promising, maybe. Maybe not. Okay. Just because we're on the free plan, we have to wait a little bit. There we go. Cool. So it's working, okay? It's working. It doesn't do anything. See? It says Wi-Fi connected, connected to MQTT, connected. Okay. For now, everything's good. Will it do something? Nope. We're not sending anything, right? Let's do that. Okay, we stop it. Okay. I will reconnect to Google Meet. Oh, okay. Let's see. For you to see that it's not that I'm sending it from this computer. Okay. We miss Tammy. Oh yeah, we always miss Tammy. Tammy's not here. That's weird. That's very weird. Usually Tammy is in my streams, but yeah, I know that you miss her so too, Karime. But hey, we have 404, and I saw Quakers and Cheese. It's been a while also, Quakers and Cheese. Cool. 006485. There we go. Let me just reconnect this. Where's my mouse? We have, oh god, we have 15 minutes. Okay. Should be an easy thing. Cool. Okay. So let me just connect to the call. Nope, not here. Should be here. I don't want it to take my image nor my microphone. There we go. Good. Should be good. I should share my screen, entire screen, share. Can you see this? Does that look good? Yeah, okay. I'll maximize this. And I'll just minimize this. Cool. Okay. So go to your Visual Studio Code. We'll rewrite publisher. Okay, it's the same thing. Okay, let's just rewrite it just in case. Okay, so it's not here. It's this one right here. Cool. So let's do Arduino pub.py. Okay. Now in Arduino pub, what we're going to do is very simple. Import, we know this, okay? We know this already. Import paho.mqtt.client as MQTT. Okay, for some reason it's not recognizing it in my libraries. It should though. Broker equals broker.hivemq.com. Okay, now topic equals, what was it? Remember? It was I don't remember. What was it? Topic here? No, topic is down. There we go. IoT garden light. Okay, that's our topic. So IoT / garden / light, like this. Okay, cool. Now client equals mqtt.client, like this, and then client.connect broker in capitals 1883, length of 60. Okay, cool. Now we'll do print. Let's do type should be on. Let's do it like this: on or off. Like this, to control the light. Type exit, all capitals, to quit. Sound good? So far, so good? Cool. Now, we'll do while true. Our command is going to be the input, okay, something that we will give through the terminal. It's going to be command dot strip dot upper, just in case. Okay, cool. Now, oh, what's wrong with my typing today? It's funny. There you go. If cmd double equals exit, then break. Okay. Else if cmd in it's either on or off. It's a fancy way of checking if your argument is either or. Client that publish, okay, where topic what cmd. Okay, yes, we send the command. Okay, else print invalid command, like this. So far so good? Cool. Okay, this should work, right? Let's test it out. If we go to terminal, and we do Python 3. Am I okay in time? Yes. Arduino pub. Bajo mat, no, bajo MQTT. There you go. Okay. It's waiting on. It says send the command on. Okay. Now it's waiting. Okay. Can I do this? Does that work? Yeah, that looks good. Okay. Yeah, nice. And maybe have this one just right here. Hey, can you see it okay? Yes. Good. So we have Arduino, and this is my computer. Okay, the other computer. Okay, cool. So this should run now. It's running. You see that? It's running. It says it's connected to MQTT, and then connected. Okay. So far, so good. Going to our call. What do you want to send? Let's send on. Okay, you see that in the terminal? Oh, check that out. We do off. How cool is that? On, off. See that? Okay, nice. Same thing as before. Okay, we have 9 minutes. Where's my call? There we go. Same thing as before. Whoever wants to run this code, please do it. Turn the light on or off. Okay. You can see in my Linux machine, it's not me. Okay. Hands off. There's a terminal. It's not me. Whoever wants to run that code is free to do so. Who wants to turn that light on or off? It's not me. I'm not doing anything. See that? Someone around the world, it's doing that. That is IoT. Isn't that cool? Yes. Someone said an on and again, off. There you go. That's IoT. That's a way to connect stuff through the internet. Wherever you are, you can do lots of things. Okay. For IoT, as I said in the beginning, try to use WalkWe. Try to use I forgot this other tool simulator. It was WalkWe and shoot, I forgot. WalkWe and let's do Arduino simulator here. Arduino sim. There we go. Tinkercad. Okay, Tinkercad is really good. Yes. Tinkercad is really good. Yes, it works. I suggest you use nope. I suggest you use simulators to learn. It's cheap. You don't have to, waste any money or spend any money, basically. If you burn something, the simulator will tell you this is wrong, you did this incorrectly, you won't lose any money. Okay? And that's it. Whenever you feel comfortable with hardware, you can buy an ESP32. It's very cheap. Or an Arduino. Careful with the Arduino. Arduino Uno has Wi-Fi integrated. Arduino Mega doesn't. You have to buy a card, an external card. Okay? Okay. Any questions? I can just put this computer just right here. Any questions? Just in case, I'll send you this for you to register again, just in case. And as the last link of the day, I'll send you this, okay? Global Hack Week feedback. If you go to that link, you will see that. What? Really? Okay, it's not phishing. Yeah, yes. That's weird. It's marking as phishing. It's not phishing, okay? It's a survey that takes 3 to 5 minutes. Okay, you click on continue, select this, and in here you do IoT. MQTT plus IoT, that's mine, okay? And for you just answer these questions, okay? For example, how would you rate the contents of this? If you really didn't like it, it's a 1 star. If you really liked it, 9 or 10 stars. I don't take anything personally. I don't know who sends. Like everything is anonymous. Okay. If I can get better, please let me know. Okay. Oh, thank you so much. That's really nice. Thank you, Karime, for the message. But yeah, any last questions? Any last thoughts? Just after this stream, we have what's next? What? Where's the? We have to register to look for the itinerary. Really? Okay, so after me comes where's MQTT? There we go. It's a Tetris mini event. Okay, and it's going to be it's tomorrow. Oh, with Cecilia. Okay, so yep, I'm the last stream of the day. Thank you, Beep Beep. Thanks for streaming, Bully. Most of these topics I usually run away from at the first chance, but I had fun. We covered a lot. Thank you so much. Don't run away. I don't like vibe coding that much, but you have to, or you can leverage that. Okay, so just in case you feel like you're not understanding something, copy paste the whole chunk of code and have the LLM explain it to you. It's really easy. But yeah, don't run from it. It's really fun. I really love IoT. Okay, if you have any questions or anything, if you want to try something and you have any more questions, is this my Discord? Discord. What's my Discord username? 4532. Or okay, so you can find me on Discord with the number or my nickname. And just in case, my GitHub's here. Okay, I'll share this repo. This is the repo where I usually have all the Global Hack Week codes that I use. Okay, when this Global Hack Week ends, I'm going to put the codes that I used in a new folder called Cloud 2026. Okay, so anything that we use today, you can use it later. Okay, cool. Thanks so much for joining. Have a nice night. Rest. Tomorrow we have interesting stuff. And yeah, thanks so much for joining. Let me know if I can help with something else. And yeah, if you have other questions related to MLH, just let me know. And yeah, if no more questions, take care. And I'll see you Thursday. It's 8 a.m. EST for Intro to Grok. Okay, so I'll see you there. Take care, y'all. Bye-bye.